and welcome back to Calculus 3 section 11.4 cross product. Yes. So to start off the cross product, we have to understand that cross product works in 3D. So I will write it here in blood, 3D. It does not work for 2D. It does not work for 4D. It does not work for 5D. It does not work for 6D. It does work for 7D. And then it does not work for 8D and so on. So there are just certain dimensions in which cross product is possible. Now we will only obviously be interested in the 3D one. So the cross product will be the product of two three-dimensional vectors, and we will see that the answer that we get is going to be another three-dimensional vector. So you guys did the class prep for this. You already know that vector you get is going to be perpendicular to the plane which is created by the two vectors that you multiplied. So the notation, so you will have to have vector u to have these three components because it must be 3D vector. Vector v also has to have three components. And the cross product between these two is going to be the procedure which you guys are going to memorize. And then there is also, well, actually, let me write the easier one first. So magnitude of u times magnitude of v times the sine of the angle in between the two vectors. So you see that this is pretty much identical formula to your dot product formula with the cosine, except now on the left-hand side you have to put the value, right? The absolute value, which is the magnitude. So the magnitude of the cross product is equal to the product of two magnitudes times sine of the angle in between the two vectors. So this is one of the formulas. But because you have to use the cross product here, and that is much more work than the dot product, you will never use this formula to find angle between two vectors. You will always use the dot product one, the cosine, because it's just much faster to compute. How do we compute cross products? You will take the determinant of the matrix I, J, K, and then U1, U2, U3, V1, V2, V3. You are going to find the determinant by breaking this one into three. For those of you who have never had linear algebra, right? You will break this into three 2 by 2 determinants, and then you will solve each one of those. So what is this equal to? You start with I, and then you will have U2, U3, V2, V3. I should put hats on all of these I, J, Ks. All right, here's the great killer. There is a minus here, and then it goes J. For U1, U3, V1, V3. I'll show patterns once I write everything out. And then K hat times U1, U2, V1, V2 determinant. Right now I need you to stare at the screen as I'm going to draw stuff and erase stuff. When I put I down, I kills the row and the column, and observe that the matrix that it's left is 2, 3, 2, 3, right? The next one over is J. When I kill off J component, observe that the matrix that it's left is 1, 3, 1, 3. Do we see that pattern? And when I put K, it's 1, 2, 1, 2. Are we all clear on this? So whatever you pick, I, J, K, you will put I, negative J, and then plus K. So whichever one you're picking, that row and that column die, and then you have the other matrix left that you have to still solve. So this is the first step. Now in linear algebra, you're going to learn that you can do this in any number of ways, right? You can do these ones are always eliminating. That's that course.
Is AD minus BC basically, right?
Yes. So now we are moving to compute each one of these. We have I times, and look at this symbol now. So it's going to be U2 times V3 minus V2 U3. Are you staring at the symbol? You follow down the symbol, and even though, look at this, it is U2 times V3 minus V2 times U3. Can't get more visual than that, all right? So you draw this symbol throughout the matrix. It is U2 V3 times V3 minus V2 U3. And then you apply that on each one of these individually. Guys, you're not memorizing this formula. You are memorizing the procedure, so kind of visually, so that you can do it. So we have U2
I'm so glad I have a
V3
teacher.
What happened?
I'm so glad you're such a visual mathematician. I'm the same way, but Calc3 is really hard like that.
Actually, me too. I'm very happy that I have myself. I spend with myself most of the time, and if I didn't like myself, man, that would be awful, because I'm stuck with myself all the time. Like, you guys go home, you take like 5-day break till next Monday. I'll be with myself those 5 days. So I'm very glad that I have myself, and I like U1 V2 minus V1 U2. There we go. So my hope is that you will not be memorizing this line, okay? Or you can, just write it 50 times, it should be good. The procedure is you pick I, then this 4, you pick J, are the n's, you pick K, are these. Don't forget this one. So it's positive I, negative J, positive K. Usually that's where the gray dies, right there. And this is going to be used a lot. I'll explain what this does. It's just mechanics now. So let's go. I'm going to leave this up. I'll put the problem on the board, and then I'll do it on the tablet. So 2 vectors. Let's say cross 2, 3, 0 with negative 1, 4, and then which number? I don't know. What number goes here? 7. Okay, thank you. I couldn't think of one. All right, so have fun. I'm going to walk a little bit and I'll come back. No coffee. Oh, should be all right.
So the reason why the government funding is so important for my major is because what we try to study is like the effects of chemicals in the you need an you need an orientation. Yeah, well, minus the teacher. Yeah.
Oh, you're right.
My mom was the English teacher. All the years I believe that, right?
Already, is there one word in red?
I mean, I even wrote it down. I just didn't know it.
No, I know, but what's the okay. I'd like to talk more about science video.
We'll pick 4 months. So this will be the first and the last time when I write it out, everything, because when I do this, you plug in your values 2, 3, 0, -1, 4, and 7. I just look at this and I write immediately the answer because in my head I just overlay, like this. So I don't necessarily write anything other than just the answer. But the first time around, I will write it out. So if you need to go back and refer, you have the video lecture. So this will be used a lot. So you need to know this procedure, and the more you practice it, the faster you will be with it. You guys want to go? Hmm? What 1 minute?
No, 0 minutes.
It's 8:20.
That's Mondays. Monday, Wednesday, 17.
Yeah, I was aiming for 8:20. It's okay if you have to go, you go. I understand that you have another class starting at 7:30. I'm just gonna finish this problem, and yeah.
And
And 11.5?
Okay, sure. No? To understand that I'm very busy. All right, so setup I, J, K, 3, 0, negative 1, 4, 7, I. So it's going to be 3047 minus J, which is 20, negative 1, 7, and then plus K, which is 2, 3, negative 1, and 4. By the way, if anyone is planning on joining any of the clubs that I'm running, stay after class and talk to me. So I is going to be 21 minus 0, minus J, 14 minus 0, and then plus K, which is 8 plus 3. And we just have a vector now, 21, negative 14, and 11. Is that what we all have?
Yeah.
Yep, that's it. The last thing that I want to say about this is what it's used for and why is it so damn important. You guys are going to have two vectors u and v, which will sit and create the plane of some sort. So this over here is a plane, and if I take and put two vectors in space and orient them in any way, right, they will always describe a plane. So no matter which way I turn this, two vectors, there will always be a plane running through them. Even if they're this way, anyway, I put them. The cross product is a vector that is perpendicular to both of those vectors. We call that the normal vector, and it will be the single vector that describes the plane. Now, you know that you have tangent line in calculus 1. In calculus 3, as the equally important concept, you have a tangent plane, where this vector is the most important vector which carries the slope of the plane. It's not the slope of the plane, but yeah. So you get that vector to the cross product. So I hope you sense how important this whole thing is. And you need to know cross product well to understand applications and further things. So this perpendicular vector to both of these is your u cross with v. It's not commutative, by the way. So u cross v is the same as negative v cross u. So we always get a vector, and the meaning of that is that if you cross u cross v, you get this vector. You do v cross u, you get this one. It's the same vector. You will have the same numbers. All the signs will be different. But they still describe the same plane. So next class, we'll do next two sections. Let me just say bye, stream.